All right, hi folks, this is Larry Maslino. I'm recording a video for Objective 16 in Alex. Objective 16 is the last objective in the course, and there's 10 topics here, and you can see most of these are asking you to do some graphing a parabola. So I want to go through some examples with you and show you how to do the graphing in Alex, and then find some different important aspects of these graphs. Now, I wanted to have the reference packet open while I'm doing this because there's going to be a lot of good information here on the reference packet. So let's get started. And let me just give you some background information on graphing parabolas. So, whenever we graph a quadratic function, notice here there's an x squared present, so this is a quadratic function. There's one of two things that can happen when you create the graph. It's either going to be a parabola that opens upward or a parabola that opens downward. So the graph is either going to look something like this or something like this. And there's an easy way to know whether the graph opens up or opens down. What you do is you look at the number in front of x squared. If the number in front of x squared, let me give you a quick example. Let's say this was y equals 3x squared plus 6x minus 2. Look at the number in front of the x squared. If that number is positive, that tells you the graph opens up. If I had an equation like negative 2x squared minus 5x plus 10, because this number in front is negative, that tells me the graph opens down. Now you don't have to remember this because here it is in the reference packet. So remember, we're thinking about the equation as ax squared plus bx plus c equals 0. And here it is right here. So what you do is you look at this number a, that's the number in front of the x squared. Here it says if a is greater than 0, the parabola opens upwards. If a is less than 0, the parabola opens down. It says here, the sign of a tells you whether the parabola opens up or opens down. All right, well, there's a couple of other important aspects of these graphs. One is we'd like to know this point right down here, which is kind of at the bottom of the roller coaster. We call this the vertex. If the graph opens down, the vertex is here at the top of the roller coaster. We call this the vertex. We're going to want to find that vertex point, because if this was my profit, let's say, at my company, this vertex would represent the maximum profit, which is a characteristic I'm interested in knowing about. So we're going to be using the vertex to answer questions about either a maximum. Notice here, this would be the maximum y on the graph when the curve opens down. Here, the vertex is the minimum y on the graph. All right, and also notice this comment on the reference sheet here. It says, if the parabola opens up, the vertex is the lowest point on the graph. So you can see that here. If the parabola opens down, then the vertex is the highest point on the graph. You could see that here. All right, there's one other aspect of these graphs that we're sometimes interested in. It's called the axis of symmetry. Notice here it says the axis of symmetry is the vertical line that goes right through the vertex. So this is the axis of symmetry, we call it. All right, we'll do some examples. This here would be the axis of symmetry in this example. All right, we'll do some examples of finding this axis of symmetry. By the way, whenever you graph a vertical line like this, the equation of a vertical line is always x equals a number. Let's say this vertex happened to be at the point 5, negative 2. Well, the equation of this green line would be x equal 5. So to write the equation of this axis of symmetry, you write the equation as x equals a number. The number to use is the x value of the vertex. All right, we'll do more examples of that in a minute. Let's come to this example. It's asking us to graph a parabola, and they're giving us y equal x squared. Well, you know, on these examples, they're going to give you specific instructions about graphing. They want you to plot 5 points on the graph. They want the vertex, then 2 points to the left and 2 points to the right of the vertex. Okay, then you're going to use a graphing function, graphing button in ALEX, and ALEX will draw the curve for you through the 5 points you plotted. All right, now one question to start with is, what is the vertex? Well, this is the very basic quadratic function. Y equal x squared is basically the simplest quadratic equation you can come up with, and that graph is always going to have a vertex at the origin, 0, 0. So the vertex is always going to be here, and this graph is going to look something like this. It's going to be a curve that opens up. And you know it opens up because the number in front of x squared is 1. Okay, this isn't a good, very nice parabola. It should be a little more curved like that. So the vertex here is 0, 0, because this graph has the vertex at the origin. The way I knew that is this was the, I'll call this the fundamental quadratic function y equal x squared. I'll show you in a few minutes how to find the vertex for any quadratic function. All right, well, here's what you're going to do for these kinds of problems. You're going to make up a little xy table. For x, you're going to pick values to use, but one value has to be the vertex. Well, I know the vertex is 0, 0 for this example, so that's one xy point I'm going to put. Then they want 2 points to the left of the vertex. So I'm going to pick -1 and -2 to go to the left. And then they want 2 points to the right. So I'm going to put +1, +2. Now to find the y value, I just use the given equation that said y equals x squared. So in this case, y is going to be -2 squared. Well, that's 4. So then the xy point here, I'll just put it in ordered pair format. This is -2, 4. What about when x equals -1? Then y is -1 squared, which is positive. So this is -1, 1. The vertex we know is 0, 0. And let me come here. When x is equal to 1, y is 1 squared, that's 1. So that's going to be 1, 1. And then when x is 2, the y value is 2 squared, that's 4. So this point is 2, 4. So now I'm going to go on the ALEX graph and graph these points. Let me go to the explanation. I'll show you a graph where this is already plotted. So let me go to the explanation. Okay, so notice here the vertex is shown as 0, 0. So here's the vertex, 0, 0. Then they pick 2 x values to the left, 2 x values to the y. To work out the corresponding y value, take the given x value, plug it into this function. That's going to get you these xy points. Now you go plot the points. All right, here is -2, 4. Here is -1, 1. Here is 0, 0. Here is 1, 1. And here is 2, 4. So you'll plot these points on the coordinate system, and then ALEX will draw the curve for you. Okay? All right, let's go to another example here. How about we do an example where we're asked for several different aspects of this graph. So let's take a look at this one. Okay. All right. So they're giving me just the graph itself. Notice they're not giving me the equation. So they just want me to find the answers here by looking at the graph only. Well, first question, does this graph open up or open down? Well, you remember, if the graph looks kind of like a U shape, that means opens up. But if the graph is pointing downwards like this, then it opens down. Clearly, in this example, our graph is opening downward. All right, it wants us now to find the coordinates of the vertex. Well, I'm going to look right here. The vertex is like the top of the roller coaster. And if you look carefully, that red dot I just drew as the vertex, it looks like it's at -3, -1. So I'm just reading that off the graph as the maximum, kind of the top of the mountain, so to speak. So this is -3, -1. All right, now they want the equation for the axis of symmetry. Well, remember, the axis of symmetry is the vertical line that goes through the vertex. So they're asking me for the equation of this green vertical line here. Well, a vertical line is always x equals a number. The number to use is whatever the x value of the vertex was. In our example, it's -3. So the answer here is going to be x equal -3. All right, now they want me to find x-intercepts and y-intercepts. Well, x-intercepts are where the graph crosses the x-axis. For example, in my example here, let's say this was x equal 2 and x equal 7. The x-intercepts in this example would be 2 and 7. I could write those as the points 2, 0 and 7, 0 if I wanted to. But in our example, our graph does not cross the x-axis at all. So in our example, there's no x-intercepts. What about the y-intercept? Well, the y-intercept is where the graph crosses the y-axis. So let me come over here, and I'm going to carefully look at this green dot. And it looks like it's crossing the y-axis at -5. So the y-intercept should be -5. All right, so this problem was just asking me to look at a graph, identify whether it opens up or opens down, also identify the vertex, the axis of symmetry. The axis of symmetry is always going to be an equation, x equals a number. For the number to use, go and grab the x value from the vertex. And then to find x and y intercepts, look at the points where the graph crosses the x-axis. In our example, it didn't cross the x-axis at all. And then for the y-intercept, where's the graph intercept or cross the y-axis? All right, well, this is using the graph itself, but what if we were working with the equation only? So let's take a look at an example like that. How about if we take a look at an equation like this that's asking us to graph this parabola, and they want us to, again, set up a table, and they want us to plot the vertex and then 2 points to the left and 2 points to the right. All right, well, what I need to do then, why don't we start off finding the vertex? So how do you find the vertex for an equation like this? First thing is, let me compare our equation to this ax squared plus bx plus c. So I want to compare our equation to ax squared plus bx plus c. When I do that, our equation is x squared plus 4x plus 9. I'm going to put a 1 in front of the x squared just to make it clear that a is 1. Our b number matches up to 4, and our c number matches up to 9. All right. I also know that this graph opens upward, right? It opens up because the number in front of x squared is a positive 1. Anytime that number in front of x squared is a positive value, I know it opens up. So I want to find the vertex, which means finding the x, y coordinates of the vertex. So let me start out. Let's find the x value of the vertex. All right, well, there's a specific formula to find the x value of the vertex. Right here it is. It says if you want to know the x value of the vertex, plug in to -b over 2a. If you work out -b over 2a, that answer is the x value of the vertex. Well, I know the b number, our b value is 4, so that's going to be -4 over 2 times a, our a value is 1, that's 2 over 1. So this is negative 4 over 2, which is negative 2. So when we want to find the vertex, we know the x value is negative 2. But we still have to find the y value. Well, anytime you know the x value and you want to find the y value, you can go back to this original equation, because this original equation gives you y if you know x. So to find the y value of the vertex now, I'm going to take our answer of negative 2, plug in x equal negative 2 in the original equation. All right, so let's do that. In our example, y is x squared plus 4x plus 9. I'm going to replace x with negative 2. Okay, let's go work that out. Negative 2 squared is negative 2 times negative 2. That's positive 4. 4 times negative 2 is a negative 8. So let's work this out. 4 plus negative 8 is negative 4. And negative 4 plus 9 is a 5. So what that means is our vertex is negative 2 comma 5. So I know this graph has a vertex at negative 2 comma 5. And I also know it opens upward, so our graph must look something like this. All right, but they want us to graph it, using the Alex graphing tool. So let's make up a table. I'm going to go to the explanation for this, but basically, here's the table we're going to make up. We're going to make up a table. I'll try to do it down here, of x, y values. I know I'm going to put the vertex of negative 2 here. And then they want 2 points to the left. So I'm going to make that negative 3 and negative 4. And then they want 2 points to the right. Well, that's going to be negative 1 and 0. And then I'm going to work out the y value by taking each of those x values and plugging it in this equation. Then I'll have the xy pairs, and I can go and plug in, then I can go and plot those points on the graph. All right, let me go to the explanation to see a nicely drawn table and graph here. So remember, our vertex was negative 2 comma 5 that we figured out. That's the first step. So let's go here to the explanation. All right. So notice they worked out here negative b over 2a. They got negative 2. They plugged in negative 2 back in the starting equation. They got 5. So the conclusion, the vertex was negative 2 comma 5. Then you come and set up this table. So notice here in the table, we put negative 2 comma 5 is like the middle row in this table, because that's the vertex. And then Alex said, plot 2 points to the left of the vertex. So we did negative 3, negative 4. Alex said, plot 2 points to the right. So we did negative 1, 0. Plug in each of those x values into this y equation. That'll give you xy points. Now let's go plot them. Okay. This point is negative 4 comma 9. This point is the plot of negative 3, 6. Down here at the very bottom is the vertex, which is at negative 2, 5. And then these points are negative 1, 6. And this point is 0 comma 9. Okay, so the important item here was to find the vertex, work out x equals negative b over 2a. Once you know the vertex, once you know the x value, plug that back into the original equation to get the y value. That'll give you the xy pair that represents the vertex. All right, let's go look at a few others. How about if we look at this example of graphing? All right, so this is going to be very similar. And again, let me just show you the explanation on this, because we're going to want to figure out A, B, and C to start with. So let's do that. I'm going to take this equation. I'm noticing that A is 2, B is 16, and C is 30. Let me find the x value, the vertex, by plugging into negative b over 2a. Our b number is 16. Our a number is 2. So this works out to be negative 16 over 4, which is negative 4. Okay, so when it comes to the vertex, we want to find the xy value. We just figured out the x value is 4, but we still need to figure out the y value. For that, take negative 4 and plug it back into the original equation. When you do that, you get negative 2. So now we know the vertex is 4, negative 2. Now it's time to graph. Well, Alex said when you're setting up this table, make the vertex the middle row. So here it is, negative 4, negative 2 is the vertex. Then plot 2 points to the left of negative 4. So I'm going to use negative 5 and negative 6. Plot 2 points to the right of negative 4, negative 3, negative 2. You'll end up with these xy values. Plot these on the graph, and you'll be able to graph this in Alex. It makes sense that this graph is opening upward, because if you think about it, the a value here was equal to 2. And if the a value is positive 2, you know the graph opens up. All right. Let's take a look here. This one wants us to find the x-intercepts in the vertex. All right, well, let's do the vertex first. To find the vertex, you remember, you use this formula that says x equals negative b over 2a. So let's compare our equation to ax squared plus bx plus c. It looks like our a matches up to negative 1. Our b matches up to negative 8. And our c value is negative 16. So let's start off to find the y value of, let's find the x value of the vertex to start with. For that, I use the handy formula negative b over 2a. By the way, you might notice here in the reference packet, they put the negative sign in front of the fraction. You could certainly do it that way. I think it's less confusing to put the negative sign on the top of the fraction. So I usually put the negative sign on the top. All right, well, then we have negative of negative 8 over 2 times negative 1. All right, let me work this out. This is going to be positive 8 over negative 2, which is negative 4. So when it comes to the vertex, we're trying to find the xy value. We just found the x value is 4. We want to find the y value. So let's now find the y value of the vertex. For that, what I'm going to do is plug in x equal negative 4 into the original equation. So it's going to be y equals negative of negative 4 squared. I got to be a little careful. Remember, I'm going to replace x with negative 4. Minus 8 times negative 4 minus 16. All right, let me keep going. This is going to be a negative. Now, negative 4 squared is positive 16. This is a negative 8 times a negative 4. That's plus 32. All right, let me keep going. This is a negative 16 plus 32. That's positive 16. Then I end up with 16 minus 16, and I get a 0. So it looks like the vertex is going to be 4, 0. Okay. All right, well, now they want me to find the x-intercepts. So this is kind of an interesting one because we just found that the vertex was 4, 0. What that tells me is the graph, and by the way, I know this opens downward, right? Because notice here our a value is negative 1 in our example. Remember, if the a value is negative, the parabola opens down. But we just found out the vertex was at 4, 0. So here's the vertex, 1, 2, 3, 4. This is the vertex. And I know the graph opens down, so this graph must do something like this. Well, I can kind of see the x-intercept already. It looks like the x-intercept is going to be here at 4. So it's just a coincidence in this example that the x-intercept and the vertex are really the same at the x value of 4. Normally that doesn't happen because normally we might get a graph that does something like this, let's say. And if we had something like this, this would be the vertex, and then the x-intercepts would be here and here. All right, well, how do you find the x-intercepts in general, though? Well, to find x-intercepts, what you do is you let y equal 0 in the starting equation and solve for x. So I'm going to let y equal 0. So let me go to this equation, y equals negative x squared minus 8x minus 16. Because I want to find x-intercepts, I let y equal 0. All right, well, now I'm going to try to factor the right-hand side of this equation. I could use the quadratic formula to solve this. I could use completing the square, but factoring might be the easiest. The only thing about factoring here is I don't want a negative x squared, right? That makes the factoring too complicated. What I'm going to do is I'm going to multiply both sides of this equation by -1. I'm allowed to do that. I can multiply both sides of the equation by any number I want. So I'm going to multiply both sides by -1. The reason I'm doing that is when I multiply -1 times negative x squared, that's going to flip it to be positive x squared. And then -1 times negative 8x flips it to be positive 8x. And -1 times negative 16 is positive 16. On the left-hand side, -1 times 0 stays 0. All right, this just makes it a little easier to factor. So now let me try to factor this. Well, it looks like it's going to factor as x plus 4 times x plus 4. Now I set each one of these parentheses separately equal to 0. You remember this as the method to solve quadratic equations. I'm going to subtract 4 here. I get x equals -4. Let me double check here. Yeah, let me double check. Oh, you know what? I mistakenly wrote the vertex as 4, 0. When we found the vertex, it was -4, comma 0. So I forgot it was -4. My mistake. Just to remind you what we did a few minutes ago, we worked out x equals -b over 2a to find the vertex. I shouldn't have erased that, I guess. And we ended up with negative of -8 over 2 times -1. That was 8 over -2, which was -4. So actually, what our graph would look like would be here at -4 is the vertex opening down like this. All right, well, when I work out these two equations, I'm ending up with x equal -4 on this side and also x equal -4 on that side. So the x-intercept here turns out to be -4, which we kind of knew already by sketching out the graph. Remember, when you go to find x-intercepts, the way to do it is let y equal 0 in the starting equation, and that will generate the x-intercepts. And you could end up with two separate answers. You know, when you have these two parentheses set equal to 0, you can end up with two different x values. And that makes sense because sometimes you will have, you know, two separate x-intercepts for the graph. All right, let's take a look and see what other, why don't we do one more example of finding mins or max? All right, so just a reminder that when you're graphing a function, a quadratic function like this, it's either going to open up or it's going to open down. All right. Now, if the graph opens up, what about the vertex? Well, if the graph opens up, the vertex is here on the very bottom. So this vertex is going to be a minimum. If the graph opens down, the vertex is up here at the top, so that's going to be a maximum. So by knowing if the graph opens up or opens down, you automatically know whether there's going to be a minimum or a maximum. If it opens up, there's going to be a minimum, but if it opens down, there's going to be a maximum. So let's look at this example. It says, does this function have a min or a max? Well, let me check out the a value here. The a value is 2, but that's a positive number. When A is a positive number, the parabola opens up. Well, if it opens up, the graph must have a minimum. So the answer here is minimum. Now it wants to know, where does the minimum or maximum occur? Well, the minimum always occurs at the vertex. The maximum always occurs at the vertex. So really this question is asking you, what is the x value of the vertex? That's really what they're asking when it says, what is the x value where the min or max occurs? Well, we've done some examples of this already. To find the x value of the vertex, we work out negative b over 2a. All right, in our example, it looks like b is negative 16, and our a number is 2. So let's plug in. This is going to be the negative of negative 16 all over 2 times 2. So that's going to be 16 over 4, which is 4. So the x value of the vertex is equal to 4. All right, let's go to the last part. What is the function's min or max value? What they're really asking you there is, what is the y value of a vertex? Well, remember how to find the y value? What you do is you plug in the x value of the vertex, in this case it's x equal 4, into the original function. So let's do that. So they're giving us y equals 2x squared minus 16x plus 28. But we want to plug in times 4 plus 28. All right, we'll work this out. Remember, all right, I think I lost my connection for a second, but I think I'm back. So I'm just going to pick up where we were finding the x value of the vertex. I'm just going to quickly, the x value of the vertex here was this question, and this turned out to be x equals negative b over 2a. That was the negative of negative 16 over 2 times 2. So that was 16 over 4, which is 4. Then we were working on the y value of the vertex. And for that, what we were doing is we were taking the original function and replacing x with 4. So it was 4 squared minus 16 times 4 plus 28. And then we were working this out. This is 2 times 16 minus 64 plus 28. That was 32 minus 64 plus 28. Let's see, that's negative 32 plus 28, which I think is negative 4. So the y value here is negative 4. The x value here was positive 4. So the vertex is at 4, comma negative 4. And we know this graph opens up. So if I was just to sketch a graph out of it, I would come over here to 4, negative 4. Here's the vertex. And this graph opens up something like this. All right, hope this is helpful as you're working in Objective 16. Please let me know if there's any questions.